So permutations and combinations, homework help. Let's start with number 1. This is a real thing in our district, right? There's a new high school. It's going to have a new name. It's going to have a new mascot, new colors. So let's pretend it's called Cypress Mountain High School. And the mascot can either be a bear, elk, or hawk. And the school color can be green, orange, or blue. This is called the fundamental counting principle. This is not permutations and combinations. It's a fancy way of saying multiply. But fundamental counting principle means take everything from your options, your number 1, choice number 1, bear, elk, or hawk. Take all of the number of choices and then multiply them by the number of choices you have in category 2, green, orange, or blue. You multiply the number of choices in each category. So category 1, how many choices? Category 2, how many choices? And you simply multiply them. So this one is literally just 3 times 3 is 9. Let's look at number 2. Someone's going to take some summer school, maybe get ahead, maybe get caught up, we don't know which one. The first session can take math or English. So in category 1, you have 2 choices. You keep it separate. For the second session, we've got art, music, keyboarding, or health. So in the next section, in category 2, we have 4 choices. You simply multiply them together, and we get 8, and that's also the fundamental counting principle. It's not, is it asking about probability? What's the probability he chooses math and then keyboarding? No, it's just asking how many different schedules can he choose, okay? Number 4, according to the road map below, how many different routes are there from the town of Aspen to Dixon? So let's do one category at a time. From Aspen to B-Town. Those are cool names. How many choices do we have? So in category 1, there's 3 choices. All right, now we're going from B-Town to Carson. How many choices? There's only 2 roads. Remember, we're taking the number of choices in each category. Okay, category number 3, there's 3 roads. Oops, I'm skipping ahead. 3 times 2 times 3. There are 18 different routes. That is the fundamental counting principle. Number 10 is when we're not just the fundamental counting principle anymore. Freshmen can choose any 5 of 9 different subjects to take, if only you only had 9 different choices, right? That would be easier to choose, right? No. And only 5 classes in a day. How many schedules are possible? So this is when you stop and you ask yourself, permutation or combination. Does order matter or does order not matter? Now, because of this word schedule, you guys know it matters if you go from math to band or from band to math. That makes a difference. You might have different people in your class. You might be more tired one period than the other. In your schedule, the order of your classes mattered. If your schedule didn't have an order, it would be anarchy, right? So the order does matter, making it a permutation. There's 9 choices, and we are choosing 5. So we go to our calculator. We type 9 first. We go to the probability menu. We choose number 2, so that it's a permutation. And then we know we're choosing 5 courses. So 9, choose 5, permutation. Wow, that's a lot of different schedules possible. I am glad I am not the counselor that has to deal with all those possibilities. Carly wants to lock her bike near the library. There are 7 slots still open in the bike rack. If she arrives at the same time as 2 other cyclists, in how many ways can they arrange their bikes? I want everyone to circle or underline or highlight that word arrange. Arrange automatically means that you are ordering it. Arrange and order are kind of synonymous, or they can be synonymous. So because I'm putting these bikes in order, because Carly, Ben, John is different than John, Carly, Ben in the order of their bikes, then because this word arrange, automatically I know it's a permutation. I know order matters. Now, there's 7 slots still open. There's 7 slots open. Carly arrives and 2 others. So we're arranging 3 bikes. 7 choose 3. 7 arrange 3. So that's a permutation. I'm not going to do the actual math. You can put that in your calculator. Ooh, part B. Carly arrived just ahead of the other 2 cyclists, and she selected a slot. So how many open slots are there now? There's only 6 open slots. How many ways can the others There's only 2 left. Arrange their bikes. The word arrange is still there, so there's 6 slots. It's a permutation, and 2 people are trying to arrange them. Okay, number 15. This one's a little bit different. Mrs. Horgan has 11 boys and 14 girls in her geometry class. How many ways can she select 2 girls to work the warm-up? This one, order doesn't matter. It doesn't matter if she chooses Lily, Angela, or Angela, Lily, because they're both going to work the warm-up, and it didn't say that it mattered who did it first. So, she's going to select girls. It has to be girls, and we want to know how many ways she can pick those girls. There's 14 girls. Order doesn't matter, and she's choosing 2 of them. So that's part A. Okay, part B. She's going to select 5 boys to put away calculators. It's going to be boys. So we know the only things we can choose from are boys. Once again, they're just putting away calculators. We don't really care about the order that she selects them. So it's a combination. It's not a permutation. 11, choose 5. C. How many ways can she select 3 students to help her grade quizzes? This is when we actually add them together. There are 25 students in her class. The order doesn't matter. And 3 of them are going to help her grade quizzes. Cool?